Right now, as you watch this, your device just did a secret little ritual, a handshake, with a machine maybe 10,000 kilometers away. It happens billions of times a second, all over the planet, and you've never once seen it. Every web page, every message, every video, none of it starts until two computers that have never met agree in 3 quick steps that they can actually hear each other. It's called the TCP Handshake. Let's slow it way down and finally watch it happen. Here's the uncomfortable truth about the internet. It's unreliable, by design. When your computer sends data, it doesn't send one neat stream. It chops it into thousands of little packets, tiny couriers, and it throws them into the network one by one. And the network makes no promises. A packet can get lost. It can show up twice. Packets can arrive in the wrong order, packet 5 before packet 2. The raw delivery layer, called IP, basically shrugs. It says, "I'll try to deliver this, no guarantees." Imagine a postal system that loses some letters, duplicates others, and shuffles the rest. That is the internet underneath. So how does anything work? How does a web page show up perfectly, one byte in place, when the road underneath is that chaotic? The answer is a layer sitting on top, doing all the hard work to fake a perfect connection. That layer is TCP. Meet our two characters. On the left, the client. That's you, your browser, your phone. On the right, the server, the machine holding the website you want. And between them, the network, a windy canyon where couriers sometimes get blown away. Now, the client could just start blasting data across immediately, but that's a terrible idea. What if the server is overloaded and not even listening? What if half the couriers can make it one way, but not the other way back? You'd be shouting into the void, never knowing if anyone heard you. So before a single byte of real data crosses, TCP insists on something polite and clever. Both sides must prove they can hear each other, in both directions. It's exactly like getting on a call. You don't launch straight into your story. First, you check. Hey, can you hear me? This is the three-way handshake. 3 messages. Watch closely. This is the part nobody explains properly. Step 1. SYN. The client sends a single packet called an SYN, short for synchronize. It's the client knocking on the door, saying, "Hi, I want to talk, and here's my starting number. Let's call it X." That number matters. The client picks a random starting number, X, and stamps it on the conversation. Every byte it sends from now on will be numbered, counting up from X. Think of it as, my tickets start at number X. Step 2. SYN ACK. The server hears the knock and sends back one packet that does 2 jobs at once. The ACK part says, "Got your SYN. I'm now expecting your next byte, number X plus 1. And the SYN part says, "Here's my starting number, Y. My tickets start at Y." See what just happened? After this one reply, the client knows the path works both ways. It shouted and it got an answer back. Step 3. ACK. The client sends the final packet, an ACK, saying, "Got your number Y. I'm now expecting Y plus 1. And with that, the server also knows the path works both ways. Both sides have now confirmed, I can hear you and you can hear me. Connection established. A little ribbon snaps between them. Quick question. Why 3 steps? Why not 2? Just knock and reply. Because 2 only proves one direction. If the client knocks and the server answers, the client knows the round trip works. But the server has no idea its own answer ever arrived. Maybe it got lost in the canyon. The third message is the server's confirmation that its number got through. 3 is the minimum to prove both directions independently. Not 2, not 4, 3. And those starting numbers, X and Y, weren't just a formality. They're the secret to everything TCP does next. Because now every single byte has a number. When real data finally flows, each chunk carries its sequence number, ticket 1, ticket 2, ticket 3. So if packets arrive out of order, ticket 5 shows up before ticket 2, the receiver just reorders them by number. The chaos of the canyon gets quietly sorted back into a perfect line. The handshake didn't just say hello, it set up the numbering system that makes reliability possible. Now the real conversation begins. The client asks for the web page, and the server starts sending it back, packet by numbered packet. And here's the move that makes TCP feel like magic. For every chunk that arrives, the receiver sends back a tiny "got it," an ACK, naming the next byte it expects. It's a constant call and response. Send, ticket 2, got 2, send 3. Send, ticket 3, got 3, send 4. A courier crosses, a thumbs up comes back. So what happens when a courier does blow away in the canyon? Simple, no thumbs up comes back. The sender waits a moment, hears nothing, and just sends it again. That's the whole trick. TCP never prevents loss. The network is still chaotic. It just notices loss and quietly resends until every numbered piece is confirmed. Lost packets, duplicates, wrong order, all of it gets healed underneath, and on top, you get a clean, perfect stream. That illusion is what the whole internet is built on. Eventually, the conversation ends. The page is loaded, the message is sent, and TCP doesn't just hang up, it says goodbye just as carefully. One side sends a FIN, "I'm done sending." The other ACKs it, "Okay, noted." Then that side sends its own FIN when it's ready and gets an ACK back. A 4-step wave goodbye, because each direction is closed on its own, so no in-flight courier gets dropped at the last second. Even the ending is polite. And that's it. That's the ritual. A SYN ACK, and an ACK to say hello, numbered tickets and thumbs ups to stay reliable, and a gentle wave to say goodbye. So the next time a page snaps onto your screen instantly, perfectly, remember what just happened underneath. Two machines that had never met did a tiny 3-step handshake across a chaotic canyon, agreed they could hear each other, and pulled a perfect conversation out of an unreliable world. Billions of times a second, all over the planet. You've used it 10,000 times today, and now, finally, you've actually seen it. A secret little ritual happening right now as you watch this.